Morning. So we're going to work on our notes for proof. So we are working today on proofs. I just have all my pens. I can't tell I like using color. So we're going to work on what is a proof. So you should have your notebook out. So we are working on what is a proof. So that's going to be page. So it's proofs and angles that we're working with. And that is going to be on page 6 and 7 in your notebook. So it's after our perimeter and area notes. So we're going to do notes. So what is a proof? And today is the 8th. Okay. So as we talked about on Friday, so there's 3 types. Okay. So the main one that we use is our 2-column proof with our statements and reasons. Okay. And then there's a flow chart. And then there is also a paragraph one. Okay. So we have our different kinds of angles. Okay. Like I said, paragraphs one that we use most. This is paragraph. Okay, so we have our angles. So we're talking about our different kinds of angles. So first one that we're gonna talk about is our vertical angles. So those are angles so those are congruent angles. Okay. And they are across from each other. So example would be angle 1 is congruent to angle 3. Angle 4 is congruent to angle 2. Okay, so this is for vertical angles. Okay, so vertical angles. So then we also have ones that are called complementary. So complementary means that they equal 90 degrees. And they can be adjacent. So adjacent means that they're next to each other. They can also be non-adjacent. Okay. So like this one. Okay. So they equal 90 degrees. So that would mean in this case that angle 1 plus angle 2 equals 90 degrees. Okay. We also said that they could be non-adjacent angles. But if we put these 2 angles together, they would equal 90. Okay. So angle 3 plus angle 4 is equal to 90. Okay, and those are called complementary. I think of that C for corner. C for corner. Right, so corner, think of the desk is 90 degrees. Okay, so it's going to be 90 degrees. Okay, so our rectangle table. Okay, so for these, supplementary, I think that of that S for straight. So supplementary angles, again, they can be adjacent or non-adjacent. They also equal 180 degrees. Okay. So we have here, so angle 1 plus angle 2, and it's equal to 180. Okay. So you'll also oftentimes see this symbol like this, showing that it's equal to 180, so it's a straight line. Okay. So those are supplementary. I think if that asks again, everybody, for a supplementary for a straight line. So that S for straight. Okay, so for straight for that one. And again, they can also be non-adjacent angles. If we add the degrees together, they would still equal 180. Okay, and you'll see those in our next unit. We can also have segment addition, and so segment addition I think is pretty important because it's talking about when we add the segments together, and we do that all the time, like if you're doing a map and you're looking at distance, okay? Or if you're measuring anything. So A to B is 5 miles, and then B to C is 3, or we could say feet. So we're measuring to make a table or something. So that means angle A plus angle BC is going to equal AC. Okay. So, or we could also do meters. So 3 meters plus 5 meters. Or we could use miles. I'll just put miles in there because I was talking about distance. Okay. So this is called the segment addition postulate. And we can do the same thing for angles as well, which is called the angle addition postulate. Okay, so we can also add these angles together. So we can have angle addition postulate as well, where we add angles together. Okay, so lots of different things that we can use. Okay, so segment addition, again, I think of it for distance. Distance, length. Lots of different things that we would use it for. Okay, so let's say that we're given, okay, that, so remember with our proofs, we're always going to start with our given. So we are given that angle 1 is congruent to angle 3. And we need to prove that angle 2 is congruent to angle 4. Okay, and we have our diagram. This is our parallel line cut by a transversal, which we'll be working with in our next unit. So we have angle 1 and 2. We have angles 3 and 4. Okay, so we need to prove that they are equal to each other. Totally move this. Yeah. All right. Okay, so remember, so we're going to do our 2-column proof. So we're going to have our statements on one side. It's always a T-chart. Okay. So we're going to have our statements on one side. And our reasons on the other side. Okay. So we always start with our given. So I'm going to put angle 1 is congruent to angle 3. Okay. So that is our given, that these two angles are congruent to each other. So the reason for that is our given. Okay, so everybody, that's always first. This is always first as our given. Okay, and then we're going to have angle 1. It's congruent to angle 2. And angle 3 is congruent to angle 4. Okay, so we have 3 is also congruent to angle 4 because they are vertical angles, so that would be the reason. Remember, we just defined vertical angles, so they are across from each other. So our vertical angle congruence. And for theorem, everybody, you're going to see us use THM. Okay. And then for vertical, all right, I'll finish the proof first. Okay, so then we're going to have angle 2. Is congruent to angle 3. Okay, and that's going to be by our transitive property of congruence, of angle congruence. Okay, so then that means that, so since angle 1 is congruent to angle 2, and angle 3 is congruent to angle 4, and 2 is congruent to angle 3, that means that angle 2 is also congruent to angle 4. Okay, so that's by our transitive property. And property, everybody, you're going to see us do it as prop. So I'm trying to show you our abbreviations that we use, that we will be using. All right, so our question for this, how can you prove angle 2 is congruent to angle 4? Okay, and I'm just going to put abbreviations here. So vertical, we do VRT. Okay, everybody, this is our angle symbol. And THM, everybody, is theorem. And then CONG, everybody, is our abbreviation for congruence. Okay. And remember, everybody, we always want to look at the diagram. So everybody always look at the diagram and see what we know. And what we knew is that those vertical angles were congruent. Okay. I'm just going to add a little symbol showing that they're parallel. All right, so let's go ahead. Our last proof. Okay, so we're gonna do one using segment addition. The document camera. Okay, so we're still working with proofs. It's the 8th. I'm going back in time. Okay, so we're going to do our diagram. So really, this would be, say, like we were just talking about a table. Say you had like a table, or outside you needed to do something. and it had this shape. And you needed to find these lengths. Okay, so we're always going to start with our given. So we're given that QR is congruent to PQ, and RS is congruent to PS. Okay, so QR is congruent to PQ. Okay. So that's this one. And then we're given that RS, okay, so maybe that's this one. So RS is congruent to PS. Sorry, PQ. I'll put the right letters down, everybody. It's PQ. Forget, double check it. PQ. Okay, so those are congruent. Okay, and we need to prove so what we need to prove, everybody, is what x is equal to. Okay, so basically what we're proving, everybody, is that we need to solve it. Okay, so we're bringing in our algebraic proofs, and everybody, you can just do an S for statements and our T-charts. Or an R for reason. Okay. So we're always going to start, everybody, so with our givens. So QR is congruent to PQ, and RS is congruent to PQ. Okay. And the reason for that is it's our given. Okay. And then we are also given, so looking at the diagram, that QR is equal to 2x plus 5. And we're also given that RS is equal to 10 minus 3x. Okay. So these are all givens. Okay. All of these are givens. So what we know now is that QR is equal to PQ, and RS, so segment RS is equal to PQ. Okay, and that's the definition of congruent segments. So if they're congruent to each other, that means that they're equal length, equal measure. Okay, and then we're going to say that QR is equal to RS because QR is equal to PQ, and PQ is also equal to RS. That means that RQ is also equal to RS. Okay, so that would be transitive property. Got these the same color. So our transitive property of equality. Okay, that means that we can also put them equal to each other. So I can put 2x plus 5 equal to 10 minus 3x. Okay, and that would be by our substitution. So we are substituting in, everybody. So think about what we're doing. We're doing our substitution property of equality. Okay. So substitution property of equality for that one, okay? And then we're going to go ahead and add, okay? So I'm going to add 3x to each side. What we do onto one side, we must do to the other side. So we're going to get 5x plus 5 is equal to 10. Okay, so everybody says that's our addition property. So we added addition property of equality. And usually everybody will just see it as addition property or addition. Okay, and then we're going to do our, we're going to subtract. So I'm going to subtract 5 from each side. So that would be 0. So then we get 5x is equal to 5. Okay, and everybody, the reason for that, again, subtraction. So it's our subtraction property of equality. Okay, and then we're going to divide. So I'm going to divide each side by 5. What we do onto one side, we must do the other side. So we get x is equal to 5. Okay, and that was our division property of equality. So, sorry. So let me see that last one again. So division property of equality. So we divided each side. Everybody, we're just going step by step. Okay, everybody, you got this.